In this video, we're going to talk about some information that you need to have in order to understand the Pythagorean theorem. We're not going to actually use the Pythagorean theorem. This right here, by the way, is the Pythagorean theorem. It's a formula. We're not going to actually, Pythagorean formula. We're not going to actually use it by plugging in numbers and doing the number crunching, but I'm going to help you understand what does A, B, and C equal, and why would you even use this formula with a right triangle. So the first thing to know is we only use this formula with a right triangle. That's the key information here. And right here I have a picture of a right triangle. I have a right triangle is one that has an angle that looks like it belongs on in a square or a rectangle. Triangle will only have one right angle, and a right angle is one that measures to be 90 degrees. It will never have more than one right angle, because if it did, it would turn into a square or a rectangle. Now, this right triangle, I should know right off the bat it's a right triangle if I have the indication here that it is right, because it has this little symbol right here that I put in here before. That little symbol tells us that, okay, it measures to be 90 degrees and it is a right angle. Now, the other thing about this right triangle is that it doesn't matter whether I flip it that way or whether I flip it that way or back to where it was before. This is still a right triangle. The measurements of the angles do not change, and the sides, how we indicate what the sides are, do not change. Here we have a squared plus b squared equals c squared is the formula we might use to help us indicate the measurements of the sides. A, B, and C refer to the sides of the right triangle. Okay, and these are all sides, what I'm highlighting in blue. Now, the thing about C is always going to be the hypotenuse. This is C. C is always this, what you might say is the diagonal side. It's the side that is opposite the angle that is 90 degrees. It is opposite the right angle. C always is referring to the hypotenuse when we use this standard formula. Now, A and B, it doesn't really matter whether you indicate that this is A and this is B, or if you want to flip it and say this is A and this is B. As long as A and B are indicating the sides, the legs of the right angle, then you're fine using this formula and plugging the numbers accordingly. But C is the one that always must be referring to the hypotenuse and no other side. And this diagonal side is called the hypotenuse. Okay, so now let's say we had this right angle, or right triangle, that, sorry, that wasn't very neat. But let's say we had that right triangle that we know the sides are, or let's say we know that A equals 3 and B equals 4 and C equals 5. When we are thinking about this formula, we must know that C is going to be referring to the hypotenuse. So right there, that tells me that 5 is the length of the diagonal. Now, which one is the 3 and which one is the 4 for the other two sides? It really just depends which one's a little bit shorter. And only by a quick visual, I might say that maybe this one is A, which is 3, and B, which is 4. Now, I'm not using units of measurement here. We can pretend and say that they're centimeters. So this is going to be 4 centimeters long, this is going to be 3 centimeters long, and this is 5 centimeters long. But as long as A and B are referring to the legs or to these two sides that are right next to this right angle, then I will be plugging in numbers correctly into this formula.